Hello, so today we'll be hopping into adding fractions. So we know that a fraction is a part of a whole. That means if you have a whole circle, for example, just using a circle as an example, and you cut this in two, you'll have one of two pieces over here and one of two pieces over here. These halves would be called fractions, right? So if we added a half and a half together, they have the same denominators. This is the rule. If they have the same denominators, you can just keep the denominator as itself and just add the numerators together. So that would be 2 over 2, which is equal to 1. So see, we get back a whole. If we had a quarter plus a quarter, the denominators are the same, so it remains. And we just add the numerators. That's 2 over 4. When you simplify it, it is equal to a half. Now, what if the denominators weren't the same? What if we were presented with something that looked like 1 over 2, which is a half, plus 1 over 3, which is a third? We can't just go and add as we did with the previous ones. We have to find something called the LCM. Now, the LCM is short for the lowest common multiple. It is simply saying the smallest multiple that can go into both 2 and 3. So I'm just going to list out some multiples of 2. So multiples of 2, you have 2, 4, 6, 8, 10, and the list goes on. Multiples of 3, you have 3, 6, 9, 12, and the list goes on. Now, there will be common multiples, but we're not looking for only common multiples, we're looking for the lowest one. So the multiple that is the lowest, it would be 6. So therefore, this becomes, so we have one big line and we have the 6 at the bottom. And then we say 2 into 6 goes 3 times, so we have 3 times 1 plus 3 into 6 goes 2 times, so we have 2 times 1, and that is now equal to 3 plus 2 over 6. The final answer is equal to 5 over 6. If we were subtracting fractions, for example, if we were subtracting 5 over 6 minus 1 over 4, the method would essentially be the same. We would first need the lowest common multiple. So the LCM is the first thing that we'd ask for. So the LCM of, so the multiples of 6 would be 6, 12, 6, 12, 18, 24, and so on. The multiples of 4 would be 4, 8, 12, 16. So immediately we see that the lowest common multiple here is 12. So we draw our line and we have our new denominator of 12. And since we're changing the denominator, we have to change the numerators so that the value of the fraction will remain the same. So 6 into 12 can go twice. So we put 2 times what was on the top, which is 5, minus, please pay attention to the sign, do not put plus by mistake, minus 4 into 12 can go 3 times, multiplied by 1, and therefore the answer will now be 10 minus 3, that is equal to 7 over 12. Now, These questions are relatively simple. However, we may also meet something called mixed fractions. So a mixed fraction will typically take on this form. You will have A and B over C. So essentially we'll see something that looks, for example, like 2.5. This simply means that you have two holes. So for example, you have two whole circles and you have a half a circle, right? So sometimes, especially on the CXC exam, we'll typically be greeted with mixed fractions. Now, if we want to add mixed fractions, the first step that we'll need to take is we'll need to convert them to improper fractions. So the way how we convert these to improper fractions is we take the denominator, which is 2, we multiply it by the whole number. So 2 times 2 is 4. Add the numerator, 1, that's 5. So 2 times 2, 4, plus 1, 5 over 2, plus 3 times 4 is 12, plus 1, that is equal to 13 over 4. So now we're left with something that we're a little bit more familiar with. So the next step that we'll need to do is we need to find the LCM. The LCM of 2 and 4 is equal to 4. So therefore we draw a line. Therefore 2 into 4 can go twice, plus 4 into 4 can go once, therefore we'll be left with 10 plus 13 over 4. That is equal to 23 over 4. Now sometimes you can leave it as a improper fraction because it's not wrong, but some teachers may want you to express it as a mixed fraction because you were working with mixed fractions in the first place, so they may want you to express it as a mixed fraction again. So now the way that you would do that would be, you say 24 divided by 4 gives me 5 wholes, and the remainder is 3 over 4. Now some persons may be a little bit confused. I'll take my time and go back over that. So if we remember our times tables, we know, if we remember 4 times tables, we know that 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16, and 5 times 4 is 20. 6 times 4 is equal to 24, correct? So just taking a look at this, we don't have 24 at the top, so therefore I know that 24 divided, I know that 24 divided by 4 would give me 6, but I don't have 24, so I say okay, 20 divided by 4 gives me 5 wholes and 3 on the outside. So essentially you want to find how many times 4 can go into 23 without a remainder. 4 can go into 23 without a remainder 5 times. And if 4 goes into 23 without a remainder 5 times, 3 is going to be left, because 4 times 5 is equal to 20. So we're left with 3 over 4. And if you want to convert it back, if you want to just double check your answer and convert it back, you'll have to see 5 times 4, 20, plus 3, 23 over 4. So now I want to do one with subtraction. Right? So I want to subtract 4.5 minus 1 1/3. So the first step, we're going to convert them to improper fractions. So now we look and we say, okay, 4 times 2, 8, plus 1, 9 over 2, minus 1 times 3 is 3, plus 1, that is 4, over 3. The LCM is equal to 6, as we previously found in a problem earlier in the video. The LCM would be equal to 6. So we say to ourselves, 2 into 6 can go 3 times. So 3 times 9, then we have our minus sign. 3 into 6 can go 2 times, so 2 times 4. That is now equal to 27 minus 8 over 6. That is equal to 19 over 6. And if you want to go and convert it back, 6 can go into 19 3 times without a remainder. So the whole number is going to be 3. 1 is going to be left, so that's going to be 3 and 1 over 6. Thank you for watching.